Okay, today we're going to talk about graphing quadratic equations. This is from Chapter 4, Section 1. And when you graph an equation that's quadratic, it's going to look like this. And it's going to say, ax squared plus bx plus c. That's how you know that it's quadratic. And then you've got a vertex, which is going to be the lowest or highest point on the parabola. And then you've got an axis of symmetry, which is going to be like a mirror image spot on your parabola. So we've taken the parabola y equals x squared. We've taken that parabola right there, and we've graphed it. It's purple. It's in purple. And so the lowest point of the parabola is the vertex. That's this guy right down here. Your vertex is at the very bottom of this particular graph. So here he is right here. That's your vertex. And then the axis of symmetry actually divides this graph in half, right down the middle, right through the vertex. And it's called the axis of symmetry. And to find the x-coordinate for that axis of symmetry, it is a vertical line. Then it's going to be x equals the opposite of b over 2a. And so that's your setup on graphing a quadratic function. These are the important things that we'll need to be aware of for graphing a quadratic. Okay, so now let's graph a quadratic equation. We've got the quadratic equation y equals 2x squared, and we're going to just go old school on this guy. Pick some points around the origin, like you used to do when you were in Algebra 1 and you were graphing just a regular linear equation. And let's pick these values for x. And remember that we've got an equation for y. Y equals 2x squared. So over here, here's my y, and this is equal to 2x squared. So let's just do that. 2 times negative 2 squared, which is 8. Okay, negative 2 squared is 4, times 2 is 8. And then 2 times negative 1 squared. Guess what this is? Just again, do your math. 2 times negative 1, or negative 1 squared is 1 times 2. 2 times 0 squared is going to be 0. And then we hit our axis of symmetry right there, because what's going to happen now is we're going to end up getting the same numbers that we got from when we did these negative versions. So it should be positive 2, not negative 2. Alright. And now we can just graph those points. And so when we do that, we get a 0, 0. Here's this guy. And then we've got negative 2, 8. So here's this guy. We've got negative 1, 2. Here's this guy. And check it out. Here's our axis of symmetry. This is where it gets kind of really cool. We've got this axis of symmetry right here. Let's move him over just a little bit. Get him perfect. Here's your axis of symmetry. So these 2 points that we've plotted on the left will now show up on the right. And they'll be the exact same in the exact same place. So negative 1, 2, and 2, 8. So these guys, all right, they're part of your axis of symmetry. And now you create a graph, but the graph is bent at that vertex. Okay, see how mine is straight right here? See, it's straight. This is not how this graph is going to look. Okay, a graph of a parabola is curvy. So what we want to do is we want to try and bend those points up, and it might be kind of hard to get a bend on the bottom. Do the best you can, especially when it's narrow. And so we're just going to bend, and it looks like this. And if we were to compare this graph to y equals x squared, if we were to compare to y equals x squared, we would see that this graph is thinner than y equals x squared. And so you graph y equals x squared on the same graph as this one and see the difference for yourself. Alright, we're going to graph the quadratic function y equals negative 1/2 x squared plus 3. and then we want to compare it to the graph of y equals x squared. So on this one, again, we want to pick some points that are close to 0. And again, just like the problem we just worked out, y has a rule, and the rule is this. It's negative 1/2 x squared plus 3. So whatever x is, we're going to use this rule. And since we're going to have to divide whatever x squared is by 2, it'll be a lot easier for us to pick evens for our x values. So let's pick 5 points again, but this time let's go with like -4, -2, 0, 2, and 4. So do these values and see what you get. Well, what you're going to end up with is -1/2 times -4 squared plus 3. So 16, positive 16, divided by 2, a -2 is 8. Okay, -8 plus 3 is -5. And then the same thing for the -2. You can punch this in on your calculator. You can write it down somewhere if you need to. But you're going to end up at 1. And then guess what happens when you're at 0? When you're at 0, it's just going to be 3. And then here is our vertex. And then we're going to have the mirror image. So now we're going to go back up from where we just came. Or I guess I should say back down. That's +4. And so plot these points. And then we'll compare it. So I go to -4, -5 point. I go to -2, 1. I go to 0, 3. And check out, here's our axis of symmetry. It happens to be on the origin. And so when I finish graphing this guy, I can just look. Look, I'm 2 units left of the line. Now I go 2 units right. I'm 1, 2, 3, 4 units left of the line. I go 1, 2, 3, 4 units left of the line. And so here's my graph. And again, it's got to be curvy on the bottom. It's not of an absolute value. So we're going to curve. I kind of missed that guy. And so here's your curve. And here's your graph of -1/2 x squared plus 3. Now, you graph y equals x squared again, and you graph it on top of this guy, and you'll see a couple of things. Number one, this graph opens down. So it's different because it opens down. Okay? It's different because it's wider, and it's different because it's moved up 3 units. Those are the things, and here they are. Look, here's the opens down part is right here, negative. That means we open down. Here's the wider part. It's that 1/2. The 1/2 makes the wider. And the up 3, that's this guy right here. And it's going to be the same every single time. Okay, let's make the difficulty a little bit more challenging here and graph y equals 2x squared minus 8x plus 6. And so when we graph this guy, we need to know what A, B, and C are. Well, here's the number A, here's the number B, here's the number C. So A is going to be 2. B is going to be -8. And C, which is our y-intercept, is going to be 6. So right off the bat, I know I'm going to go through the line right here. That point is on my graph. The next thing that I want to do is find my axis of symmetry. Well, that's the opposite of B over 2A. That's the opposite of B over 2A. And this is the first part of the quadratic formula. You've seen it before. It is the first part of the quadratic formula. So what do I end up with? I end up with 8 over 4 or 2. So when the x-coordinate is 2, I've got my axis of symmetry. So what does that mean? That means that right here, when my x-coordinate is 2, I'm going to have an axis of symmetry. Okay? Right off the bat, I have another point on my graph. Because of the axis of symmetry, my y-intercept right here, also notice it's 2 units from the axis of symmetry. I have another point that's also 2 units away. So how can we figure out some other points that go on this graph? Well, let's just make the good old-fashioned T-chart. But this time, in the middle, I'm going to have an x-coordinate of 2. So let's use 1 and 0. Well, we know that 0 is going to be 6 because that's our y-intercept. And then when we put 1 in, what do you get? Well, you've got 2 times 1 squared minus 8 times 1 plus 6. That's going to be my y-coordinate. Okay? So what is that number specifically? I don't know. We can work it out. This is going to be 2 minus 8. So 2 minus 8 is negative 6. Plus 6 is 0. So the point 1, 0 is on my graph. Well, if it's on the graph here, because of my axis of symmetry, it'll be on the graph right here. And then we can check the point at 2. This is going to be my vertex. So 2 times 2 squared minus 8 times 2 plus 6. And when I do this, 2 squared is 4, times 2 is 8. So this is 8. 8 times 2 is 16. So 8 minus 8 plus 6. 8 minus 16 is negative 8, plus 6 is negative 2. Okay? So this is going to be at negative 2, negative 2. That's going to be my vertex. And look, here's my graph. And it was done fairly painlessly. And it's going to be thinner than an x squared. It's going to be moved over a little bit from the origin. But it's going to look like this. And that's all there is to it. And you can always double check yourself. Put in 3 and 4 into your original equation. And check and see and make sure that you get the point 3, 0 and the point 4, 6. Okay, the last big thing to figure out is, do we have a maximum or a minimum with this quadratic function, y equals 3x squared minus 18x plus 20? Well, what we need to do is we need to look at our function and determine, is this opening term positive or negative? If a is greater than 0, if a is greater than 0, then your parabola is going to open like this. If a is less than 0, your parabola is going to open like this. Well, guess what? This guy right here is going to have a minimum value. This guy right here is going to have a maximum value. So when we look at our parabola, we see that 3x squared. In this case, 3 is greater than 0. This is true. So this graph is going to have a minimum value. It's going to have a minimum value. Well, where is that minimum value happen? All we need to know is the x-coordinate for the axis of symmetry. And x is equal to the opposite of b over 2a. So, here's a, here's b, and those are the only two numbers that we need. How does it work? Well, if a is 3 and b is negative 18, then what you're going to have is x equals the opposite of b over 2a. Well, 18 divided by 6 is 3. That's the x-coordinate for my vertex. Okay? So if this is the x-coordinate, how do I find y? I've got the equation right here. Y equals 3x squared minus 18x plus 20. What goes in for all the x's? We just found it out. The 3. So you end up with my y-coordinate being 3 times 3 squared minus 18 times 3 plus 20. And when you punch all that into your calculator or do it out longhand, what are you going to have? Well, you're going to have 3 times 9 minus 54 plus 20, which is 27, minus 54 plus 20, which I believe when you put all of that together is going to be 7. So what is my minimum value? My minimum value occurs at the point 3, 7, which is also my vertex. Okay?